for today's story is the fact that I forgot to press record. I recorded a very cool episode on Processes 101 from Linux Fundamentals Part 3. And yes, that's it. We have to redo it all over again. Processes are the programs that are running on your machine. They are managed by the kernel, where each process will have an ID associated with it, also known as its PID. The PID increments for the order in which the process starts. That is, the 60th process. The 60th process will have a PID of 60. We can view processes by using the ps command. We can use the friendly ps command to provide a list of the running processes as our user session and some additional information such as its status code, the session that is running it. Come on, Daniel. The cat is having a very uncomfortable position as usual. Information such as status code, the session that is running it, how much usage time of the CPU it is using, and the name of the actual program or command that is being executed. And here we can see, by using the ps command, we can see actually two examples because it ran ps command one after another. We can see the PID, the session that is running it, and the time and the process. Also here we can see highlighted in red boxes, running commands one after another. We can see they increment by 1. That will be also explained in the following. Note how in the screenshot above, the second process, PS, has a PID of 204. And then in the command below it, this is then incremented to 205. To see the process run by other users and those that don't run from a session that is system processes, we need to provide the auxiliary to the ps command like so, ps aux.
You know, if you know, Daniel.
He will sleep in a second. All right. And here we can see the ps auxiliary command being used. You can see here for all the users, the PIDs and all the information needed, much more than we had on only the ps command. Note how we now have root and CM and a TIC as users. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insights into your system is via the top command. And here we can see the top command being used. Managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate to exact how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriate name kill command and the associated PID that we wish to kill. That is, to kill PID 1337, we'd use kill 1337. Below are some of the signals that we can send to a process when it is killed. So in other words, we can kill a process by doing specific things with it. In other words, sigterm will kill the process, but allows it to do some cleanup tasks beforehand. Ckill will kill the process, but doesn't do any cleanup after the fact. And sigstop just stops or suspends the process. How do processes start? Let's start off by talking about namespaces. The operating system uses namespaces to ultimately split up the resources available on the computer to, such as CPU, RAM, and priority processes. Think of it as splitting your computer up into slices, similar to a cake. Processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. This process is the system's init on Ubuntu, such as systemd, which is used to provide a way of managing a user's processes and sits in between the operating system and the user. For example, once a system boots and it initialized, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it is controlled by systemd, but will run as its own process, although sharing the resources from systemd to make it easier for us to identify and the likes. Here we can see the first process that it starts, it's systemd. Getting processes, services to start on a boot. Some applications can be started on the boot of the system that we know. For example, web servers, database servers, or file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. In the example, we're going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Enter the use of systemctl. This command allows us to interact with the systemd process daemon. Continuing on with our example, systemctl is an easy to use command that takes the following formatting: systemctl, then the option, and then the service. Here we can see the 4 options used by systemctl. For example, to tell Apache to start up, we'll use systemctl for the option start and for the service Apache 2. Seems simple enough, right? Same with if we want to stop Apache, we just replace the option with stop instead of start like we provided. We can do 4 options with systemctl: start, stop, enable, disable. An introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states, in the background and in the foreground. For example, commands that you run in the terminal such as echo or things of that sort will run in the foreground of your terminal, as it is the only command provided that hasn't been told to run in the background. Echo is a great example, as the output of echo will return to you in the foreground but wouldn't in the background. Take the screenshot below, for example. Here we see the use of the same command echo hi TryHackMe, but in the first one it's just a simple use hi TryHackMe. In the second one we use the AND operator, where that is used, we use AND to background a process or to run a process in a background or a command in the background. Here we're running echo hi TryHackMe, where we expect the outputs to be returned to us like it is at the start, but after adding the AND operator to the command, we're instead just given the idea of the echo process rather than the actual output, as it is running in the background. And here we can see this is great for commands such as copying files, because it means that we can run the command in the background and continue on with our whatever further command we wish to execute without having to wait for the file copy to finish first. We can do the exact same when executing things like scripts. Rather than relying on the AND operator, we can use Ctrl-Z on our keyboard to background the process. It is also an effective way of pausing the execution of a script or command, like in the example below. And here we can see the use of a script that runs all the time. It hit Ctrl-Z and the process is in the background. This script will keep on repeating. The message, this will keep on looping until I stop or suspend the process by Ctrl+Z, as indicated by T and Z. Now our terminal is no longer filled up with messages until we foreground it, which we will discuss below. Foregrounding a process. Now that we have a process running in the background, for example our script background.ch, we can which can be confirmed by using the ps-ox command. We can backpedal and bring this process back to the foreground to interact with. Here we can see the use of ps-ox. We can see under the user root, we can see our stopped script with our process backgrounded using either Ctrl-Z or the end operator. We can use the FG for foreground to bring this back to the focus like below, where we can see the FG command is being used to bring the background process back into use on the terminal, where the output of the script is now returned to us. We can see the simple use of FG command. The script will start again. Answer the questions below. README. Amazing. If we were to launch a process where the previous ID was 300, what would the ID of this new process be? We know that it will be incremented by 1. If we wanted to cleanly kill a process, what signal would we send it? We can go over here at the kill command, managing processes kill command, and we can see for a cleanup, we need sig term. Locate the process that is running on the deployed instance. What flag is given? For this to answer, you have to need to deploy the Linux machine, and then you have to connect to the SSH, and then to connect to the SSH, you just use the SSH command, username at IP, login with the password TryHackMe, and then use ps-ox. You will see this flag. I believe under the process ID 486. It maybe will be changed, but I found it, I believe, under 486, something like that. What command would we use to stop the service, my service? For this, we can go to here, to systemctl command, and we can see that it has 4 options. For this, we need the stop option for my service. What command would we use to start the same service on the boot up of the system? For that, we need enable systemctl enable my service. What command would we use to bring a previously backgrounded process back to the foreground? The FG command. And that's it, folks.